In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet evaluating functions. Our directions for this entire worksheet are to simply evaluate each function. And how we evaluate a function is we're going to take the value of the variable, plug it in, and simplify. So let's dive into number 1. So in number 1, we have our function h of t, and that's equal to the absolute value of t plus 2 plus 3. So what we're going to do is we're going to plug 6 in everywhere we have t. So we're going to have h of 6 equal to the absolute value of, remember we're plugging 6 in for t. So we're going to have 6 plus 2, that absolute value, plus 3. Again, all we're doing is taking t and plugging 6 in for t. So what's this going to equal? Well, the absolute value of 6 plus 2 is the absolute value of 8, and we're adding 3. The absolute value of 8 is 8, plus 3 will give us 11. So 11 is our solution for h of 6 in number 1. Let's move on to number 2. In number 2, we have the function g of a equal to 3 to the 3a minus 2. And what we're going to evaluate is g of 1. So we're going to be plugging 1 in for a and solving. So g of 1 is going to be equal to 3 to the 3 times, what are we doing? We're plugging 1 in for a, so that's 3 times 1 minus 2. This is going to be evaluated to 3 to the, 3 times 1 is 3, minus 2 is 1. 3 to the first is equal to 3. So 3 is our solution in number 2. Again, for this function, we're just taking this value of 1 and plugging it in for a. Let's move on to number 3. For number 3, our function w of t is equal to negative 2t plus 1. Another way we can think about this, if you want to think about it in terms of x and y, w is kind of like y, and this is equal to negative 2 times x plus 1. But what's our x value? It's what we're plugging into our function, that negative 7. So we're taking that value and plugging it right on in to solve for y. Essentially, we're getting the value of our function at negative 7. So w of t equals negative 2t plus 1. So w of negative 7 equals negative 2 times negative 7 plus 1. Plugging negative 7 in for t. So negative 2 times a negative 7, negative times a negative is a positive. So that's going to equal a positive 14 plus 1, which equals 15. So w of negative 7 is equal to 15. Moving on to number 4, g of x equals 3x minus 3, and we're finding g of negative 6. So g of negative 6 is going to be equal to 3 times negative 6 minus 3, plugging negative 6 in for x. So 3 times negative 6 is a negative 18, and we're subtracting 3 from that. Negative 18 minus 3 is a negative 21. And that's our solution for number 4. For number 5, h of n is equal to negative 2n squared plus 4. What we're doing is we're plugging 4 in for n. So h of 4 is going to equal negative 2 times 4 squared plus 4. Again, I'm plugging 4 right on in for n. Remembering our order of operations, and if you need a quick refresher, I'll leave a card up here, so feel free to click that video and review. But we need to do exponents first. So 4 squared is going to equal 16, so we'll have negative 2 times a positive 16 plus 4. Negative 2 times 16 is going to be a negative 32, and when we add 4 to that, that's going to be a negative 28. So negative 28 is our solution for number 5. In number 6, h of t is equal to negative 2 times 5 to the negative t minus 1. We want to find h of negative 2. So h of negative 2 is going to equal negative 2 times 5 to the negative. For t, we are plugging in negative 2. So because we have a negative t, we're going to have negative of negative 2, which eventually will evaluate to a positive 2, but we're plugging this entire quantity in for t. So I like to plug it in before I start simplifying just to make sure I've plugged in that full quantity. So negative t is negative 2 minus 1. This is going to be equal to negative 2 times 5 to the, well, just as we stated, the opposite of negative 2 is a positive 2. Subtracting 1 is 1. So this is negative 2 times 5 to the first, or negative 2 times 5, which gives us a negative 10. For number 7, our function f of x is equal to x squared minus 3x. We're going to be finding f of negative 8. What that means is we're plugging negative 8 right on in for our variable x. So f of negative 8 is going to equal negative 8, that quantity squared, minus 3 times negative 8. Notice in this problem, I had two separate x variables, so I had to plug my negative 8 in two separate times. Wherever I see an x, I'm plugging in that negative 8. So evaluating this, a negative 8 squared is going to be a positive 64, and we're subtracting 3 times a negative 8, which will be subtracting a negative 24. Subtracting a negative is the same as adding a positive, so this is really 64 plus 24, which is going to equal 88. 88 is our solution. In number 8, p of a equals negative 4 to the 3a. We're plugging in negative 1 for a. We're going to find p of negative 1. That's going to be equal to negative 4 to the 3 times, well, plugging in negative 1 for a, that's 3 times negative 1. Negative 4 to the 3 times negative 1 is negative 4 to the negative 3. And how do we evaluate negative 4 to the negative 3? Well, remember, a negative exponent can be written as a positive exponent in the denominator of a fraction. So I'm going to write this as 1 over negative 4 to the positive 3. If you need a refresher on those negative exponents, again, I'll leave a card over here or a link in the description below, so check out those if you need a quick refresher. Now all we need to do is take negative 4 and raise it to a power of 3. So this is going to be a negative 4 times a negative 4 times a negative 4, which is going to result in a negative. So I know ultimately my answer is negative, and it's going to be negative 1 over 4 cubed, which is 64. So negative 1/64 is my solution in number 8. Moving right along to number 9, we have p of t equals 4t minus 5. We want to find p of t minus 2. What's different about this problem is, look, we're going to be plugging in some expression into our variable, not just a number. So if we're finding p of t minus 2, that means that everywhere in our original function where we have a t, I'm plugging in t minus 2. So when I see this t here, I need to plug in this entire quantity t minus 2. That means we're going to have 4 times t, which we're plugging in t minus 2 in for t, so that's 4 times t minus 2 minus 5. Again, this is very important to note that we plug in the entire expression into our function. So because we're plugging in t minus 2, when we see that t, we're plugging in t minus 2. So evaluating this, we just need to distribute the 4 and simplify as much as we can. 4 times t is 4t minus 4 times 2, which is minus 8, minus 5. 4t minus 8 minus 5. I'm taking a negative 8 and subtracting 5, so that's the same as a negative 13. So we're going to have 4t minus 13. We can't simplify this expression down any further, so this is our solution. When we plug in t minus 2 for t, p of t minus 2 equals 4t minus 13. And if it was confusing plugging in t minus 2 for t, well, think about this original t as some other variable, let's say x. We're plugging in t minus 2 in for x. So when we get to that x, we're plugging in that entire expression. Let's move on to number 10. Number 10, we have g of a equals 4a. We want to find g of 2a. That means wherever there's an a in our original function, we're plugging in 2a instead. So we have 4 times, not a, but 2a. 4 times 2a is going to be 4 times 2 times a, which is 8a. That's our solution for number 10. Number 11, we have w of n equals 4n plus 2. We're plugging in 3n to our function. So w of 3n is going to equal 4 times 3n plus 2. 4 times 3n is 12n plus 2. Can't simplify any further. This is just 12n plus 2. Number 12, w of a equals a plus 3. We're going to find w of a plus 4. So w of a plus 4 is going to equal, what are we plugging in for a? We're plugging in an a plus 4. So a plus 4 plus 3. Again, we're plugging in a plus 4 in for a. A plus 4 plus 3 is a plus 7. Let's move on to number 13. For 13, h of x equals 4x minus 2. We're going to find h of x plus 2. So that's going to be equal to 4 times x plus 2 minus 2, because we're plugging in x plus 2 everywhere we see an x. So 4 times x plus 2 minus 2, distributing that 4 into our parentheses, we're going to get 4x plus 8. Again, that was 4 times x plus 4 times 2 minus 2 equals 4x plus 6. That's our solution for number 13. For number 14, k of a equals negative 4 to the 3a plus 2. We're going to be finding k of a minus 2. So that's going to be equal to negative 4 times 3 to the, we're plugging in a minus 2 in for a. So that's 3 times the quantity a minus 2, keeping parentheses around it since we're going to need to distribute, plus 2. This is equal to negative 4 to the 3 times a is 3a minus 3 times 2 is 6 plus 2. Distributing that 3 to the a and the minus 2. Simplifying down further, we have negative 4 to the 3a, negative 6 plus 2 is the negative 4. So negative 4 to the 3a minus 4. That's our solution for number 14, since we can't simplify down any further. For number 15, g of n equals n cubed minus 5n squared. We're going to be finding g of negative 4n. So plugging in negative 4n everywhere we see an n. So we have negative 4n cubed minus 5 times negative 4n squared. And it's important to keep the parentheses around that negative 4n, because when we cube it, we're going to cube both the 4 and the n, and also when we square it, we need to square both the negative 4 and n as well. So negative 4 cubed is going to be a negative 64, and that's times n cubed minus 5 times negative 4 squared is a positive 16, and n squared is n squared. Simplifying a bit further, we can combine this 5 times the 16. So we'll have negative 64 n cubed minus 5 times 16, which is 80, and that's multiplied by n squared. So again, negative 64 n cubed minus 80 n squared. And I want to reiterate the fact that it's important to keep the parentheses around what we're plugging into our function. That way, we correctly execute the order of operations. Let's move on to number 16. For number 16, our function is f of n. What we want to find is f of n squared. So everywhere there's n in my original function, I'm plugging in an n squared. So I have n squared squared minus 2 times n squared. Again, everywhere there was an n, I plugged in an n squared. N squared squared. What do we do to those exponents? Remembering our properties of exponents, we multiply them together. And if you need a quick refresher, again, I'll leave a card over here. But continuing on, n squared squared is n to the 2 times 2, which is n to the 4th, and we're subtracting 2n squared from that quantity. So n to the 4th minus 2n squared is the solution in number 16. Continuing on to number 17, if you've been finding this video helpful so far, please let me know by clicking the thumbs up button down below. But anyway, moving right along, we have p of a equals a cubed minus 5. We want to find p of x minus 4. That means we're plugging in x minus 4 everywhere we have an a in our function. So p of x minus 4 equals x minus 4 cubed minus 5. Now because we're cubing this, we're going to have to do some expanding of this polynomial. What this is x minus 4 times x minus 4 times x minus 4, that's x minus 4 cubed minus 5. We cannot, I repeat, we cannot simply distribute this through. That is not allowed. We need to expand out this polynomial. We can never distribute an exponent through when we have addition or subtraction. We need to expand it all out, multiplying each of my terms. So focusing on these first two binomials first, x times x is x squared, minus x times 4 is minus 4x, minus 4 times x is another minus 4x, and then negative 4 times negative 4 is a positive 16. So that's expanding out my first two binomials, which I'll simplify down because negative 4x minus 4x is a negative 8x. So I have x squared minus 8x plus 16, and I'm going to multiply that by x minus 4, and then finally subtract 5 from that quantity. Next, I'll distribute, expanding out these two polynomials. So x squared times x is x cubed, minus x squared times 4 is minus a 4x squared. Moving on to my 8x, negative 8x times x is a negative 8x squared. Negative 8x times a negative 4 is a positive 32x. And then lastly, 16. 16 times x is a positive 16x. And 16 times negative 4 is a negative 64. And from all of this, I'm subtracting 5. Now, if you notice, we can combine some like terms. Negative 4x squared and negative 8x squared can be combined together to a negative 12x squared. So simplifying that, we'll have x cubed minus negative 12x squared. And then notice that 32x can be combined with 16x. Adding those together, we'll get a 48x. So plus 48x. And then finally, combining my negative 64 and my negative 5, that's going to give me negative 69. So my solution for number 17, after I've expanded out my polynomial, is x cubed minus 12x squared plus 48x minus 69. Finally, on to our last problem, number 18. We have h of t, and we're going to find h of 4 plus t. So that's going to be equal to 2 times 3 to the, in our function we have t plus 3, but what are we plugging in for t? We're plugging in 4 plus t. So that's going to be 3 to the 4 plus t plus 3. Simplifying this down, we'll have 2 times 3 to the 4 plus t plus 3 is 7 plus t. We can't simplify any further, so 2 times 3 to the 7 plus t is our final solution on this worksheet. Again, I'll leave a link in the description below so you know how to access this free Infinite Algebra 2 worksheet. If you have any questions, leave them in the comments below and I or one of your peers will respond as soon as we can. As always, don't forget to like, subscribe, and share. Happy learning!